Okay, this is a continuation from the notes from yesterday. Yesterday, we covered everything that looks like this, and we found out how to shift a graph up, down, left, and right. Remember that the H controls left and right, as we see right here. The H controls the left and right, but make sure that you write it as a subtraction problem. And then the K controls up and down. We're going to do the same thing, but we're going to go ahead and mess with the function a little bit differently. Just as a reminder, let's go ahead and remember what our parent graph looks like. So I'm going to go ahead and jot this down. This is going to be the same stuff from yesterday. This is the parent graph. Everything revolves around the absolute value of x because I cannot make it any simpler than that. And if you remember, the absolute value of x had the values that look like this. It was 5, 4, 3, 2, 1, 0. And then it got reflected around the 0, and so it became 1, 2, 3, 4, 5. If I were to graph that, it would go negative 5, 5 here, and it would go down one, right one, down one, right one, down one, right one, all the way until it got to the 0, and then it would go up one, right one, up one, right one, up one, right one, up one, right one, all the way. Remember that when you guys are doing this, make sure that you're using a ruler and that you're using graph paper because these graphs need to be pretty precise so that they don't run into each other unnecessarily and you're getting the wrong points to pop out, okay? Now, a couple of things that we were supposed to notice is that, number one, this parent graph looks like a V. And again, this is the exact same thing we wrote yesterday, so it should look exactly like that first graph, right? And the other stuff that we noticed was that the vertex was at 0, 0. That's this guy right here, okay? The vertex is going to be basically where we're going to be starting our graph to make it easier on us. Vertex at 0, 0. That's also where the line of symmetry is going to occur at x equals 0. And then the last thing we want to talk about is that this graph goes up in both directions. So that takes care of the parent graph. We're not going to need a highlighter for that. You will need 3 highlighters today since we're doing 3 graphs aside from the parent graph. All right, so let's take a look at g of x and see what's happening here. In this case, with the g of x, what we're doing is we're taking a 2 and we're multiplying it on the outside right next to that absolute value of x. We haven't done that at all. So far, all we've done is either add or subtracted a number to the absolute value, sometimes inside the absolute value, sometimes on the outside. This time, we're going to actually multiply that by 2. So let's see how we're going to tackle this. We're going to take that negative 5, we're going to put it in here. Negative 5, when I multiply it, when I take the absolute value of negative 5, it's 5. So now I have 2 times 5, and then 2 times 5 is going to be 10. I'm going to take the negative 4, substitute it in. Absolute value of negative 4 is 4, and now I have a 2 times 4, which is going to give me an 8. Negative 3, I'm going to pop it in. Absolute value of negative 3 is 3. 2 times 3, that's going to give me a 6. And if I keep doing this, I'm going to get 4, 2, and 0. When I start popping in the 1, when I substitute the 1, I'm going to get 2 times the absolute value of 1, which is 1. And then 2 times 1 is 2. So the reflection is starting to occur there. And I think you guys are pretty good noticing that once you hit that reflection piece where it kind of mirrors going this way and this way, then the numbers are going to repeat. So because it's 2, 4, 6, 8, 10 going this way, then it's going to be 2, 4, 6, 8, 10 going this way. I already hit the part where it reflects over. Now we're going to go ahead and take those values and plot them. The first one I see is negative 5, 10, but that doesn't fit on my graph. So I'm going to skip that one. We're going to go to the next one, which is negative 4, 8. Negative 4, 8 is right up here. And then the next coordinate that I have is negative 3, 6. Then negative 2, 4, negative 1, 2, 0, 0. And then that's when the reflection occurs and it starts bouncing back up. So the next point is 1, 2, 2, 4, 3, 6, 4, 8. Again, we're going to go ahead and take that ruler, connect this line. This is going to be my new line. And in an effort to try to get these organized and make it so that they stand out, I'm going to go ahead and highlight this yellow. So my g of x, which was 2 times the absolute value of x, is going to be in yellow. And we're going to start asking ourselves, how does this compare to the original graph, which is the one that's not highlighted? It didn't shift, right? It actually stayed in the same spot. The vertex is still at 0, 0, so we're not going to be talking about a shift in this case. What I do notice is that it's skinnier, right? In mathematics, we're going to say that this is a vertical stretch. It's like I grabbed the original graph and I stretched it up and down, right? Almost like a rubber band, and made it longer and skinnier vertically, okay? So we're going to say that this gave it a vertical stretch. More importantly, guys, and especially on the homework that you guys are going to get today, it's going to be the exact same graph as before. It's just each one of these y values got multiplied by 2. So for example, when I look at this, this is the coordinate 1, comma 2 right here, okay? And if I take just this value and I multiply it by 2, then what I end up with is 1, comma, whoop, no, I'm sorry, let's try that again. This is the coordinate 1, comma 1. What I'm trying to say is if I take that y value and I just multiply it by 2, then I end up with 1, comma 2, which is exactly where this ended up. Check out this one right here. This is the coordinate 4, comma 4. But if I just take the y value and I multiply it by 2, then what I end up with is the coordinate 4, comma 8. And that's exactly where this new point is at. It's now at 4, comma 8. Okay, so if you want to see how do we actually graph this, all I have to do is take the original graph, keep the x value the same, so don't move it left and right, but we are going to double however high it is. So it was 3 units high, now it's 6 units high. It was 4 units high, now it's 8 units high. And that doubling action is coming from here. If that would have been a 3, then obviously you would have tripled all the y values and make it 3 times as high as it was before. All right? So that's what happens when you multiply a number by 2. In this case, we're going to go ahead and start working with h of x, which means I'm going to multiply it by a half. And that's a little bit harder to see. So try to take a conjecture, try to come up with hypotheses. What do you think is going to happen? And we're going to actually figure out what's going to happen, okay? I'm going to use decimals instead of that fraction just because I think it's a little bit easier for you to graph the decimals than it is to graph the functions. So let's see. I'm going to take the -5. This one is probably the most difficult one to make a table for. I'm going to go ahead and substitute it right there. Absolute value of -5 is just 5. And if I take 5 times a half, that's the same thing as taking half of 5. Half of 5 is 2.5. So 2.5 is what I get to write down. Next one, I'm going to go ahead and take the -4 and I'm going to substitute it in here. Absolute value of -4 is 4. So now I'm taking 4 times a half. Remember, that's half of 4. Half of 4 is 2. And if I continue doing this, -3, that turns into a +3. Half of 3, that becomes 1.5. Then I get 1, 0.5, and 0, because half of 0 is 0. And once I get to this 1, I'm going to substitute it. Absolute value of 1 is 1. And if I take half of 1, then what I get is 0.5, and that's where my reflection takes place. That means all the numbers going this way are going to be the exact as all the numbers going that way. So I can go ahead and fill out the rest of my table. I'm going to get 1, 1.5, 2, and 2.5. Let's go ahead and graph those values and see what this looks like. I'm going to have -5 and 2.5. -5 and 2.5, that would be 2.5. That goes right here. At -4, I'm at 2. -3 is 1.5. -2 is 1. And I get something that looks like this. That's where it bounces. So going in the opposite direction, I get it at a half, at 1, 1.5, 2, and 2.5. I'm going to use a ruler to connect these. And I'm going to go ahead and use my green highlighter. Whoops, that's not a highlighter. Let's try that again. That's the wrong color. Let's try that again. There we go. I'm going to use my green highlighter to highlight my h of x, which again is me taking my absolute value of x and multiplying it by a half. So this new graph is this one here. How does that relate to my original graph, which is the one that's not highlighted at all? Well, it's the same graph. It did not shift. However, it did it looks like it got squished, right? Like if it was a can and I'm like all of a sudden stepping on that can, all of a sudden it's just kind of flattening out, or maybe even better yet, like a ball of Play-Doh, right? If it was a ball of Play-Doh, all of a sudden it's looking squished, right? It's kind of spreading out. So what we're gonna say is that this thing got vertically compressed. To compress something is to squish it, right? To make it smaller and fatter. So we're gonna say that this is the same as f of x, but vertically compressed. Same as f of x, but vertically compressed. Just like last time, I could get that from my original graph. I just need to take the y values, but instead, so this was the point 1 comma 1. I'm just going to take that y value and take half of it. So now it becomes 1 comma 0.5, and that's exactly where this ended up. If I take this one over here, this is the point 5 comma 5. If I want to know what the new one is, I'm just going to take half of that 5. Half of that 5 is 2.5. So I'm at the point 5 comma 2.5. 5 comma 2.5 is exactly this point right here. Okay. So what does this number in front control? This controls whether it gets vertically stretched if the number that you're multiplying is bigger than 1, and it's vertically compressed if the number in front of it is less than 1. All right, and then the last thing we're going to look at is what about if I have this negative in front of the absolute value? This is another one that's kind of weird to see, so I'm going to do the first three relatively slowly, and then you can go, and then I'm going to go ahead and jump after that. Okay, so here we go. So first one, I'm going to substitute this in. I'm going to take the absolute value of negative 5, which is 5. But since the absolute value of negative 5 is 5, I still have this negative in the front. So the answer is actually going to be a negative 5. In fact, I'm going to go ahead and do this one, but I'm going to actually write it down so you can kind of see the progression. So I'm going to go ahead and substitute negative 4 into this function. What ends up happening is I have the negative absolute value of negative 4. Now, I know the absolute value of negative 4. The absolute value of negative 4 is just 4. So right here, I'm just going to write that this is just 4. However, that is this. I still have this negative on the outside, so I need to bring that negative down. And the answer I get is negative 4. Hopefully that made more sense why that answer is negative. In that same fashion, I'm going to take that negative 3. I'm going to substitute it in. Absolute value of negative 3 is just a positive 3, but I still have this negative on the outside, so the answer is going to be negative 3. And if I continue doing this, I'm going to get negative 2, negative 1. Technically, it would be negative 0, but negative 0 is just 0. When I substitute the 1 in here, I'm going to take the absolute value of 1, which is just 1. But again, I still have that negative in the front, so this becomes negative 1. And it looks like this is where it got reflected again. My line of symmetry is right at x equals 0. And that means all these numbers are going to repeat going left and right. So I get negative 2, negative 3, negative 4, negative 5. When I start plotting this, I end up with negative 5, negative 5, negative 4, negative 4, negative 3, negative 3, going up like this, and then it reflects at 0 and it starts going down this way. Make sure you're using a ruler on this so that we get those clean looking graphs. I'm going to go ahead and highlight this one pink. This is my j of x. And how does this graph look like the original graph? And I know it's kind of convoluted, but the original graph is this one right here. And this is the exact same size. You see how this one's going up one, right one, up one, right one, up one, right one, up right one. And this one's going down one, right one, down one, right one, down one, right one, down one, right one. So it's the exact same size. It's not vertically stretched. It's not vertically compressed. It has the exact same size as before, okay? The only difference is instead of going up, both of these arrows are going down. So we're able to flip this thing. So I'm going to write that this one is the only one that goes down, and we say that it gets flipped over the x-axis. Okay, so that's all the cases that we have so far. So now I have that a in front of the x minus h plus k. So let's just kind of recap what everything does. I know that this h in here controls how much you move left and right. I know that this k right here controls up and down. And then the last thing is I know that this a up here controls whether this is a vertical stretch, that means long and skinny, or compression, that means short and fat, depending on whether the number in the front is bigger than 1, it's going to stretch, or less than 1, then it's going to compress. And I'm just talking about the number, I'm not talking about the sign, okay? This A also controls whether this is going concave. Let me go ahead and let me write that it's whether it's pointing up or whether the graph is going to point down. That's being controlled by whether that's a positive or negative. If that's a positive number in the front, then it's going to be pointing upwards. If it's going to be a negative number in the front, then it's going to flip it over the x-axis, and now it's going to be pointing downwards. Okay, the other thing I want to talk about is all of these that didn't have a number in the front, like these guys right here. Remember that there's an imaginary 1 right here? And so technically that is a positive 1, which means that's why all your graphs were pointing upwards like this, okay? So just keep that in mind, that there is a number in the front. It's just 1. That's why it's not being compressed. That's why it's not being stretched, right? That's why all of them look the same. All right, guys, that's all I have for today. If you have any other questions, please feel free to let me know.